Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The starting material is a 1,2,4-trioxolane, ozonide, the product of ozonolysis of an alkene. In ozonolysis, an alkene RCH is equal to Cr2, where one carbon bears H and R, the other bears to R groups, is converted to an ozonide via the JEE mechanism. The ozonide is a 5-membered ring containing one ether oxygen and one peroxide, O, linkage. Reductive workup with dimethyl sulfide, Me2S, cleaves the ozonide, oxidizing Me2S to Me2S is equal to O, DMSO, while reducing the ozonide to the corresponding carbonyl fragments. Reasoning: the ozonide structure shown has one carbon bearing H and R. This carbon came from the RCH is equal to end of the original alkene, and one carbon bearing to R groups. This carbon came from the is equal to Cr2 end. Upon reductive cleavage with Me2S, the carbon bearing H and R gives an aldehyde, IChO. The carbon bearing to R groups gives a ketone, Rc, is equal to O, R. Both carbonyl compounds are produced simultaneously as product A. Why other options fail? Option A, alone, Rc, is equal to O, R, ketone, is incomplete because the aldehyde fragment is also formed. Option B, alone, IChO, aldehyde, is incomplete because the ketone fragment is also formed. Option C, R-CO2H, carboxylic acid, would only form under oxidative workup conditions, example, H2O2, O3H2O, not with the reductive Me2S workup. Option D correctly states both A and B are formed, which matches the ozonolysis reductive workup mechanism. Therefore, the correct answer is D. Therefore, the correct answer is option D.